So hello everyone and welcome to Electronic Technocrat. So today's tutorial will be all about the second categorization of the simple diode logic gate, that is, any guesses? Yes, the AND gate. That's correct. Alright, so today's video will be completely emphasizing on this particular topic about the AND gate. The AND gate is a second categorization topic of the simple diode logic gate. In the last video, we saw everything about OR gate and how is it used, how it works, and we also derived the truth table. Alright, so without wasting any time, let's just start our video. Before starting, there's a very important announcement. My very close friend Sudhanshu Jadhav has started a new channel called as Where's My Tech. Alright, so that channel is all about information about the latest technologies, the gadgets, the confirmed and speculated rumors about the upcoming devices in the country. So do make sure you subscribe to him, like his videos, share his channel all over the contacts you have on your WhatsApp, Instagram, Facebook, YouTube, anywhere you can share it, LinkedIn, Reddit, anywhere you can share it. Make sure you subscribe that guy. He's a very fantastic guy. I've seen his videos as well. He's just started his new channel, so the link will be given to his channel in the description below, so make sure you like it. Alright, so let's move on to our AND gate working first of all. Now, a very conventional way of telling you how the AND gate works, just like I introduced this way in the previous video as well. Alright, so what do we have here? We have two diodes being connected here. Alright, just like this last one, only thing these are connected in the reverse bias condition, that is in this direction. Alright, in the last video, the OR gate, the two diodes were connected in this direction. Alright, so I think it should be very clear to you that this is a NAND gate. Alright, so without wasting any time, let's start our video. As you can see, there are two diodes here. Alright, and there is one output. So according to that, I'll be drawing a truth table for you. Alright, so that it will be very much easier for you to understand as well. Before that, I will tell you how the AND gate actually looks like. Yeah, symbolically. Perfect. A symbolical example of AND gate. Alright, how does it look like? The AND gate, sorry, my bad. The AND gate looks like this. Okay, so the shapes are not going good here. Sorry, pardon me. Alright, okay, here we go. This is the AND gate. This is the output Z and two inputs, X and Y. Now again, I'll be telling you these two. This is a symbolic diagram of what we are studying here. This is the circuit diagram. To avoid any confusion, these two are equivalent diagrams, so don't confuse yourself. While explaining this diagram, I am explaining the symbols working as well, along with the truth table. Alright, so it is clear. So the first input is X, the second input is Y, and the output is Z. As I have told you, the logic gates generally have two inputs and one output. The only exception case is, yes, correct, the NOT gate. It has got one input and one output. Alright, so let's start our thing here. So the first input that we will give is, alright, okay, so the first input that we will give is 0, 0. I will be writing it a bit aside from the diagram so that I can fit all the numbers here. Alright. So the first input is 0, 0. So the AND gate basically tells us that whenever you have got two inputs, that is 0, 0, that is logic level low, then we have no output in the output section, that is 0. That's correct. The output will be 0. When there is no input given, the outputs will be automatically equal to 0. Alright, The next case will be 0, 1. Alright, when one input is 0 and one input is 1, or we can say that when one of the inputs of the AND gate is connected to logic high. Now again I'll be revising you what is logic high. Logic high represents the binary number 1 and logic low represents the binary number 0. So whenever I will speak the term logic high, it is 1, and whenever I will speak the term logic low, it is the binary number 0. Alright, so when one of the inputs of the AND gate is connected to the logic high and other is connected to the logic low, that is, one is connected to logic high and one is connected to logic low, or vice versa. It can be also different. One can be connected as logic high here and one can be connected as logic low here. Both cases are same. Only thing is the inputs exchange these binary numbers. Alright, then these diodes are said to be in reverse bias. Yes, you have heard this term before, right? The reverse bias. Do you know what is it? What is it? Yes, correct. The reverse bias is an arrangement in a PN junction diode in which no current flows at all. There's a blockage of current. Correct. The blockage of current. Alright. No current is flowing through the PN junction diode in this condition. So, what do you understand by this? If one of the input is 1, like here the second case as well. If any one of the input is 1 and the other one is 0, the output will again be 0. Alright? Do you get that? If any of the input is 1 and the next one is 0, and if any of the input again is 1 and if another one is again 0, we will get the output as zeros. So till now, if both the inputs are 0, we get an output as 0. This is the condition of the AND gate. Then again these two conditions are similar conditions, or I can just write same here, same conditions. Keeping either of the input as 1 and the next input as 0, you still get an output that is 0. Now the fourth case would be if both the inputs are 1. What will be the output? Yes, correct. The output will be 1. Perfect. If the two inputs are connected to logic high, then the diodes are in the forward bias condition. The diodes will be in the forward bias condition. Now, forward bias condition, you know about forward bias condition, right? Yes, that's correct. You're absolutely getting a champion on it, right? So, the forward bias condition basically means that the circuit, that is a PN junction diode, it is an arrangement in which, or we can say a PN junction diode device, or a device basically, a PN junction device, in which there is a large amount of current being flowing in just, yes, one direction. In just a single direction, there's a large amount of current being flowing. So, when you give one input as 1 and the next input as 1 as well, so we get an output that is 1. That's correct. So we have verified all the conditions. When both the inputs are 0, we get an output as 0. When one of the inputs is 1 and the next one is 0, we still get outputs as 0. And when both are 1s, we get an output that is 1. So we have verified the truth table using this circuit diagram. Now why not take a real life example, right? So let's take a real life example. This is the bulb experiment, bulb and switch experiment, just like I've shown you in the last video as well. Let's understand the truth table by this bulb and switch experiment. Alright, I will draw the table for you here. The X input, the Y input and the Z input. 0, 0, 0, 1, 1, 0, 1, 1. So you're singing along with me, right? Yeah, it's so simple when you sing along with me and study as well. So, the first case would be Here we go, the first case. In this, both the inputs are 0, 0. So both the switch, as you can see, are off condition. So the bulb will not glow. Alright, so the output will be correct, 0. When one condition here, let's see the second condition here. When one condition is 0 and one condition is 1, that is one input is 0 and one input is 1. What did I tell you? Exactly. The conditions are very similar to that of the truth table shown right here. Here we go. 0, 1, 1, 0. What we get in output is 0, 0. That's correct. Alright. So, when one input is 1 and one input is 0, the output will still be 0. That means the bulb will not glow. Again, when one input is 1 and one input is 0, the same case will happen. The output will not show any result or the bulb will not glow. Now, when both the inputs are 1, the output will certainly be 1. That is correct. Sorry, I will write it here. The output will be 1. Why so? Because as you can see, both the switches are in the on condition. So the current is flowing through this AND gate, and through this AND gate it's going to the bulb, making the bulb glow. Now, the very important thing that I wanted to tell you, the AND gate has got the Boolean equation as x dot y. You are correct. The Z is the output, obviously. The x and the y both are the inputs. Alright, so let's verify the condition using, this is called as the Boolean equation. Alright, let's now verify this Boolean equation according to this truth table. I will write it here. When the Z is equal to, now Z is equal to, when one case is 0 and another case is 0, the output we get it as 0, because 0 multiplied by 0 is 0, or 0 and 0 is 0. When one input is 1 and the next input is 0, it is still 0. That is, when one input is 1 and it is ANDed with 0, then the output is 0 again. Now when one input is 0 and one input is 1, the output is again 0. That is, when one input is 0 and one input is ANDed with 1, the output will still remain 0. And the last condition is when one input is 1 and it is ANDed with the next input that is also 1, we will get an output as 1. So if you logically see, this ANDing is nothing but multiplying. If you see 0 into 0 is 0, 1 into 0 is 0, 0 into 1 is 0, and 1 into 1 is 1. Alright, this is just a multiplication to be more precise. Alright, so we have again simplified our understanding here along with this real life example again, and also the Boolean equation. So, you finding it still difficult? Don't worry, I've got a very interesting example for you again waiting for you. Yes, perfect. This is a burglar alarm experiment. That's correct. The first one was the bulb and switch experiment, and now this is the burglar alarm experiment. Sorry, my bad. So, what does this experiment tell you? This is a real life example. Again, I'm telling you, just like this example. This example is a real life example as well. This type of system is being used in our day-to-day life, as you can see. So, let's start. Here you can see one sensor that is a person sensor, another sensor that is an alarm switch. Basically, now there are many types of person sensors available for us in the market, or it can be a variety of person sensors and alarm switches. So some of them would be the PIR sensor, a microwave sensor, an ultrasonic sensor, a video camera software, a gesture detector. So it can be any kind of a thing here. Alright, and the alarm switches, they are also available in variety of types. They can be ultrasonic sensor, they can be a micro detector, they can be a motion sensor, They can be infrasound detectors, there can be glass break detections, smoke, heat, blah blah. So many sensors are available in the market. Alright, this, as you can see, is the AND gate. So as I'm telling you the real life application, you can clearly see there's an AND gate here, and this is the burglar alarm. Okay, so this is an alarm, and this is obviously a thief. Haha, that's correct. So the person sensor that I'll be using here would be basically a PIR sensor for my convenience. Now, what is a PIR sensor basically? Whenever I talk about a PIR sensor, it is abbreviated as passive infrared detectors. I won't go into depth about it, just tell you why we are using it here, or what is the use of PIR sensor here. A PIR sensors, to be strictly speaking, are not used to detect the motion. Is that clear? We do not use PIR sensor as a motion detector. They only detect the sudden or abrupt changes in the temperature at a given set of point. So whenever a thief actually, or an intruder basically, walks in front of this sensor, what happens is the temperature at that point will rise from the room temperature to the body temperature of this thief. This quick change detects the, or we can say triggers the detection. So we can use a PIR sensor here, and the alarm switch, I will be basically using an alarm switch that is an ultrasonic. That is my favorite sensor, the ultrasonic sensor. That's correct, the ultrasonic. Ultrasonic sensors are those sensors that have the frequencies between 15 kilohertz to 75 kilohertz. And these are basically active detectors that transmit ultrasound waves. Alright? So, whenever the surfaces are stationary in ultrasonic sensor, stationary in the sense, whatever the object or whatever the thing is in front of the sensor, and it is not moving at all, it is still, that is called as stationary. The frequency of these waves detected by the receiver will be equal to the transmitted frequency. Alright, it is very much a difficult concept of ultrasonic sensor. I won't be going to depth. Now here I am using the ultrasonic sensor as a alarm switch and PIR sensor as a person sensor. Alright, so this ultrasonic sensor will be acting as an alarm signal or an alarm switch. Whenever such kind of event happens, whenever it finds that there is some movement been occurring, basically the ultrasonic sensor will alert me, and the PIR sensor, it will detect any person or any object. Alright, so both of them are having almost similar operations. Alright, so it's very interesting, isn't it? So our truth table would be 0 0 0 1 1 0 and 1 1. Alright, so according to this diagram, let's start our explanation. When the person sensor has got an input as 0 and the alarm switch has got an input 0, what will be the output? Yes, the burglar alarm will not ring at all. Alright, so the output will be 0. And when the person sensor has got an input 0 and the alarm switch has got an input as 1, the burglar alarm will not ring again. It has got an output 0, just like we have studied in the previous slides about the AND gate property. Alright, again when I give 1 to the person sensor as an input and 0 to the alarm switch as an input, we get an output as 0. So the alarm will not ring again. Alright, so it fails again. But this case is very interesting. When both the sensors have got an input as 1, now we get an output as 1 here. The burglar alarm will basically ring at its maximum value, and after ringing as a maximum value, you can see this thief running for his life because the alarm is absolutely ringing at his whole new volume. And why is it so? And why is it ringing so badly? Because the person sensor has got an input as 1 and the alarm switch has got an input as 1. So we get an output as 1. Here we go. We have updated the table as well. So as soon as the person sensor detects the person by the infrared, or we can say the temperature changes, that is the PIS sensor detects the human or the thief by abruptly seeing the temperature changes, and ultrasonic sensor actually determines the or triggers the alarm event. When both of them have like suspicion about something is happening, both these sensors are suspicious about something is happening in front of us, then they will trigger the alarm and tell the house owner that a thief is trying to loot your property. So please catch that thief. Now, if you're lucky enough, that thief will be in your house itself, that is, you have trapped him in your prey, that is, he's a prey of your trap, or he is very, very intelligent to escape through all of this, even after the alarm is being triggered. So, it's on you basically. He is running for his life. So, it's a very real life example. It's a very interesting and a very interesting, or we can say, it happens in everyday life as well. So this burglar alarm experiment is very useful application of the AND gate. So I hope you understand what is an AND gate and how does it work. So I'll be ending this lecture. Thank you very much for being a patient audience. And till then, bye bye and take care. And also just look out for these thieves. Alright? So thank you very much. Have a good day.